Hello, this is the Read the Stress podcast episode number 13, Angular 2.0. My name is Stefanake Cornell and I will be the host for today's episode. Unfortunately, Eric won't be able to join us today, so we wish him the best in this very special day for him. And our guest today is Miško Hevery, and he's going to present us today Zone.js. Miško, can you please introduce yourself?
Hi, my name is Miško Hevery. I work on the Angular 2 project. I guess I'm the person who started the whole Angular thing. So you can blame me for all these things. And today I want to, you're welcome. And today what I wanted to show you is a specific aspect of Angular 2, which is the problem of change detection. How do we know that something in the system has changed and we have to update the UI? Should I just talk about it?
Yes, please.
Okay, so Angular 2, just to give you kind of a heads up, we have just released beta. We're super excited about it. And what beta really means is that we think we have gotten all major breaking changes behind us. And going forward, we are going to focus on adding features. And if there will be a breaking change, we're going to go through a proper deprecation strategy. So because of that, we think it's ready for kind of a general use and starting to get to be used on large-scale projects. So now's a good time to jump on if you wanted to go. Now, for those of you who used Angular 1, you know there was this magical method in Angular 1 called the digest, the $digest. And at special times, it was necessary to call $digest or $apply so that you can update in the UI, and the UI would reflect the changes. So we have a very simple demo of Angular 2, which is in here. Sorry, let's see. Oops. Then here's the source code for it. Actually, the more important is the HTML. Here we go. So here's the HTML. And all it is that when I type name, you can see my typing updates the UI. So the question is, really, how does Angular know at what point is it necessary to go and update the bindings? Because as you can see that ng model sets it to your name, and then at some point, Angular has to go read the your name property and update the heading h1. So how does Angular know that? And to answer the question, there is a separate library we have built called Zone.js. So what is a zone? I think it's best to kind of explain it in a form of an example. So Zone allows us to intercept all of the asynchronous APIs in the browser. So we basically, what Zone does is it monkey patches the world and every single async API in the browser and allows for interception. Now, why is this useful? This is useful because in the browser, the only way something can actually happen is as a response to an external event coming in. Right? So when I start typing on the keyboard, the input starts firing change events. And so what we need is we need to take that change event and not only update the property, but also go reflect that property in HTML, in this case of a heading. So how do we know that? How do we know that a change has happened? We do because somewhere in the code base, somebody at some point had to do add event listener on the input element for a key up and key down, or for a change event or something of that sort. And when that happens, we have to remember in Angular 1, we had to remember at the end of it to call $digest. But we wanted to automate this in Angular 2. And so what we wanted to do is to automatically have Zone notice that the registration has happened and automatically append the digest call in there. Now, at first, it may sound like that's pretty easy. We'll do that. But not all events need to have essentially the change detection attached to it. So for example, if you have a mouse move, or if you have a request animation frame going on, many behaviors that we happen to do in a system should not have change detection running. And it's not so as simple as simply saying that if we have request animation frame, then we shouldn't do it. But if we have a mouse event, then we should. It really depends on what the intent of the developer is. So for example, a developer might say that a set timeout sometimes might have to have a change detection on it, and sometimes it might not. And all of this really depends on what is the intent. Is the intent that I will do a set timeout in 500 milliseconds so that I can clear a butter bar of the screen, in which case the change detection has to run. But if the intent is to just animate something, and then change detection should not have run. So knowing that a set timeout gets called is insufficient information for us to decide whether or not change detection should run. So here comes the zones. So zones, step 1 is to monkey patch the world so we can intercept these things. And step 2 is to provide context, kind of like the intent of what we want to do. And it's best explained in this example. So at the very beginning, we have what we call a root zone. This is a zone that doesn't really do anything from what any existing browser already does. In other words, we kind of monkey patch the world, we kind of get the zone ready. But when you call any API on the browser, you cannot see any different behavior. It's kind of a pass-through, do-nothing operation. What we can do is we can fork it, and the forked zone can have additional information on it. And so you can think of the zone as kind of a global variable. So once you fork it, you can run it, and we can, say, for example, say that we are setting a property called in the zone to be true. Now, notice that when this run method finishes executing, the console that runs over here prints zone in the zone, and it's false, right? Because the root zone, when we forked it and we ran what's inside of it, this is running inside of a zone. Once this run method completes, it's now back out of the zone, and the zone kind of got restored to the previous state. And the original state was that we are not in the zone. So when you execute this will run immediately and will reprint false. So far, nothing magical is happening. Now, set timeout executes. We schedule work to be executed in a little bit. And inside of there, we print out the value of zone in the zone. And notice what happens. The variable of in the zone got restored for the duration of the set timeout back to true. In other words, the zone remembered that the set timeout that was executed inside of this piece of code was really registered when the zone had a particular property set, and it restores that property when the set timeout executes. If we were to move this piece of code, the set timeout code, outside of the forking and the run function and just place it over here, the answer to this question would be true. So what we have done is we're kind of remembering, we can think of the zone kind of like a thread local variable, and we always remember the state on subsequent asynchronous operations. So when we start up Angular, we entered the Angular zone, and one of the features of Angular zone is that it tells Angular whenever the asynchronous operation is completed. And so on the completion, we can execute change detection. We can run the code to kind of update all the UI. But within your code, within your application code, you could have, for example, scheduled a set timeout. But because that set timeout will be scheduled from within Angular zone, when the set timeout callback finally executes, the execution of that callback will again be inside of the same Angular zone, which will then know to do change detection. But if I schedule a request animation frame outside of the Angular zone, then the callback will also run outside of the zone. And because it's running outside, there will be no change detection, right? So we have taken this world where whatever the state of whether or not we want to do change detection happens to be, if we schedule an asynchronous operation, the subsequent asynchronous operation will also have the same behavior as the original one. So unless we do stuff to intentionally change the zone by either forking it or executing something in a different zone, the mental model is that all the subsequent asynchronous operations should have the same exact behavior as the original one that started it, right? And so now we get to control things like, do we want change detection or not, is purely controlled as to who scheduled this particular work. So if we register on event listener, for example, on a click button, if it was registered from within Angular, then the Angular will get to be notified of the change detection. But if it's registered outside of Angular, then it will have no impact on the behavior of the system. Does that kind of make sense?
Yes.
I know it's a little too much to get one's mind around it. But anyway, so this is what zones do.
Do
So
we
a couple of
have
examples. Yes, go ahead.
one question? Once we are forking a zone, it means that we are creating a new one, right?
Correct.
So do we have any inheritance between the original and the forked one?
That yes, we do. So you can think of a zone just as a regular JavaScript object, and when you fork a zone, you prototypically inherit from that object and create a new zone. And so the new zone will obviously prototypically get all the properties from the zone above it, but it can add or override its own properties. And so what zones allow you to do, let's see, there's all these hooks that we, for example, have, so we can be notified of whenever a task is complete. We can let's see, when things are created, when things are destroyed, if an error happens within the asynchronous task, who should be handling it, and lots of typical things that you would deal with asynchronous operations. So basically, everything that has to do with asynchronous operations can be intercepted by the zone, and you can be notified about it. And what exactly one has to do with that information is declared in the zone, and it's inherited between asynchronous operations, right? So if a particular asynchronous operation started with in a Angular mental model, then we will contain to have the Angular error handling code, the Angular change detection, and Angular processing. But if it started outside of the Angular zone, then Angular will not be notified of it. And so that's how we keep these things separate. And so you can actually have two applications running on the same page. You could have an Angular application, let's say, and let's say you have another application written using a different framework. We can correctly discern which asynchronous operations were triggered by Angular, and therefore which need change detections and which did not get triggered. And the beauty of that is that in Angular 1x, whenever we wanted to, for example, do set timeout 0, we couldn't just use set timeout 0. We had to do $timeout, right? Specifically because we needed to distinguish between we need to be able to be notified that the callback happens so that we can do $digest. And this just happens automatically now with the zones, because we monkey patch the main one, but we do it in such a way that we don't interfere with the rest of the code base that might be running on the browser. Okay, now, what are the common? Yes.
With Angular 1, whenever you were triggering digest, you were able to check if a digest is already in progress. So you won't create a new one.
That's right.
So with this one, will rendering happen with each zone execution?
So with this one, you really don't have to think about it, because you can just assume that the digest is always running, and any asynchronous operation that you call will automatically have the zone running as well, because the zones are inherited asynchronously. And as a result, there is no really need to check this, because you can just assume that eventually somebody will run this. You don't have to, because in the Angular one, you manually have to be like, oh, I think I need to run digest. And so you run digest, but then you have to be like, oh, am I already running? Because it might be called synchronously or asynchronously, and you're not sure, so you have to check. Here, the whole problem just goes away, because you just know that when the task is done, you will be notified. The other way to look at it is that zone allows you to detect the VM turns, right? So the C code of the browser and the VM of the V8 take turns about who's running. They go back and forth. And in between, we do rendering. And so, but there's no really good way of knowing like when the code begins to run, the JavaScript code, and when it finishes. Right? Like you can remember each time that there's an asynchronous operation to kind of mark it, but like you would like to have this in the automated way. And that's what Zone has done, because we intercepted every single asynchronous API that we could find. We can automatically see like, oh, every VM turn is a result of an event. So every time we enter, we know that there is some event happening, whether it's a click, the server-side response, set timeout, or any of the other asynchronous tasks that we have. will trigger a zone of execution. And we can know about it, we can wrap it, we can do try catch, we can do error handling, and so on. So before we start talking about how all this stuff works, I want to talk about a little bit about a couple of useful examples of what zones are good for. So one example of a zone we have is called a long stack trace. So I'm sure you've seen this particular problem, which is that you get an error message and there's a stack trace and it takes you only to the last event. And so it says something like, XHR had an event, the data showed up, and for whatever reason, the data is bad. But really, you would like to know, like, well, what was the request URL that actually triggered it, right? Or because you know that the XHR could have been triggered by many, many different locations. You really want to know the full stack trace of who did the triggering. With normal synchronous threads, you don't have that because the stack trace will just take you all the way to the event being fired. But because zones can actually track individual who actually enqueued it, every time we fork a zone, we can take a snapshot of a stack trace. And then we can get a full stack trace. We can simply say, okay, well, what is the full stack trace? So we'll show you, okay, so you are in this particular point where the error was thrown. If you go back in time, eventually you're going to read XHR, which had the change event. But then you get like a line across and says, but this was actually triggered 500 milliseconds earlier by invocation to a method called the .send. And if you go down the stack trace, you eventually see, oh, .send got triggered because a user clicked on something, right? And again, you'll see a line saying, well, and the registration actually happened 30 seconds ago on the application Bootstrap. And this is the stack trace, which did actually the registration of the event for that button, which then caused an XHR, which then returned with an error. And that's super useful, right?
I can see that.
And this usefulness actually comes because you can get this for any code base. So you can take any existing application, install the Angular zone, install zone, and into the zone you fork it with the stack trace, long stack trace zone, and as a result, you then bootstrap your application inside of this long stack trace zone, and as a result, all of the behavior of the application will have the long stack trace automatically inserted in there. Now, if, for example, let's say there is an ad served on the page, and the ad was not bootstrapped in the Angular zone, then it will not have to pay the cost of capturing the stack traces because it has a separate zone and has a separate set of rules. So when it schedules its asynchronous operation, then the asynchronous operation doesn't actually capture the stack trace because capturing stack trace is expensive, so you don't want to do it all the time. And so this is how you can kind of break this down into different zones or domains or realms, whatever you want to call it, and kind of keep things in check. So we talked about long stack trace. What else could we use zones for? Well, you could also use it for unit testing, right? You could have a unit testing zone, which would allow you to intercept all, for example, asynchronous scheduling, like set timeout, or listening to add event listener, and they could automatically clean them up. So the simplest thing would be like, let me just do a unit test where I register a whole bunch of listeners and then click on stuff, and then I can ask the zone to verify that I properly cleaned up all the callbacks, because the zone knows which callbacks you registered with which elements. You can either ask the zone to automatically clean it up, or you could say, well, verify that like I properly cleaned up all the listeners, that they can be released. And this is an example of what a zone could do. Another thing they could do is it could say, well, why don't you intercept all calls to alert, so that in my unit test, instead of like popping up an actual alert box, right, it just goes into some kind of a log, and then I can assert in my unit test that a specific thing actually got alerted without actually having anybody to click on it. Another thing we could do is, for example, we can intercept a set timeout and essentially turn a asynchronous test that is going to wait for set timeout 0 into a synchronous one by saying, okay, why don't you pretend that the time has moved forward and then execute the timeout callback and assert that the right stuff actually happened. So these are all different kinds of examples of what a zone can do once you're able to kind of keep track of the genealogy. Okay?
Yes.
So So on the core of it is this idea of keeping track of the genealogy of the zone, which means that when I schedule a callback, like in this case, when I schedule the set timeout, I have to make sure that before this function executes, this callback function, I properly restore the zone global variable to the correct state, right? And then when the function is finished, the zone variable gets restored back to the original no-op zone, so that in case of execution of something like this, it would look like just a no-op.
Okay.
Right? So the question is, how do we do this? How do we do this? Okay, so in Zone.js, there's this one file called browser.js, and this basically contains all of the APIs in the browser that are synchronous. And it's a long list, and we're not going to go through all of them. So you have things like set timeout, clear timeout, animation frames, alert prompt, which kind of we alluded to earlier, event target delegation, property descriptors, promises, mutation observers, geolocations, file reader, fetches. Like, these are all examples of asynchronous APIs, so a place where you pass in a callback, but the callback gets executed at some later point in time, right? Not synchronously, but asynchronously. Okay, and so we need to intercept it so that we can properly wrap these callbacks in the try catch and also in proper zone restorations, etc. So let's have a look at one of these. So let's look at, generally we call this the set clear function set. So this is the set timeout, clear timeout, set interval, clear interval, set immediate, clear intermediate, request animation, cancel animation, right? These are all set of methods that we are well familiar with in our day-to-day programming of JavaScript, but we want to intercept them so that we can keep track of this. So let's have a look how this is done. Okay, so the first thing we do, we grab the original native methods, right? So this is the original. So let's pretend we're doing a timeout to make this. This is a generic code for all methods, but let's pretend for a second that we're doing a timeout. So we grab the native set timeout and we grab the native clear timeout. Now, timeouts actually can be canceled. So we need to keep track of outstanding list of IDs. These are the set of set timeouts that have been scheduled but haven't maybe had run yet, or maybe the application decides to cancel them. So just going to keep the outstanding ones in here for now. Now, if we have a native method, one of the things we want to do is WTF. Let's ignore this for a second. We'll come back to it in a second. So the first thing we need to do is we simply override the set method and say, well, actually, whenever you go to the window and call the set method, what we want you to do is to just forward the call to the current zone. So this is the global variable zone. And we forward it on to the current zone, set timeout, and we apply the arguments, right? So any call to set timeout actually gets redirected to the root of the application. So into the current zone, and the current zone can then choose to intercept it further if it wants to. And because the zone variable gets restored and then saved and restored, different zones can have different behavior for what it means to be in this particular case. So the next thing we do is we actually add a same exact method to zone. So this set timeout that we took from window is now also going to be available on the zone. And it's all in the form of take a function and a delay. And the next thing we do is we this is some error checking in here. What we do is we capture the current zone. So whenever somebody invoked set zone, we need to know, like, what is the current zone? So we simply just capture it, right? And by capturing the current zone, we're going to be using this to restore it later. We're also going to capture the set ID. And now what we need to do is we need to take the first argument, which is the function, and we need to override it with the function that basically does the magic. And so what we're just doing is we're just wrapping it. And so the wrapped function then eventually gets passed on. We'll come back to the wrapping process in a second, but it gets passed into the native piece of code. So we call the native function, we apply the native function with the window and arguments So we actually invoke it, take the set ID, we store it in a set of sets, and then we do some WTF stuff. That's not important. So, but notice what we did is we wrapped the callback, and this is where the magic is. When the set timeout executes at some point later in time, what we do is we execute the callback. But before we do that, we save the current zone. So we say, okay, whatever the current zone is, we're gonna have to restore it later. So let's just save this. I'm sorry, that's where this has happened. So this is where we call it. All right, so we have the callback zone right here, and we're saying execute the callback function in this other zone. So this callback zone, there are certain rules under which we fork the zone, but essentially it is the zone we saved over here, right? So this zone that we saved here becomes here. We may or may not fork it, and then the callback zone says execute the next piece of work inside of the zone. And what this piece of code does is it restores the zone. It runs it in try-catch block. So in case there's an error handling, it can process that as well. And executes the original function that was passed in with all of the arguments in here. And so what we have done is when we re-enter the zone, when we re-enter the set timeout callback, we have properly restored the zone. And then when everything is done, we exit it. Now, there's a couple more things we do here, but before we talk about the other stuff, do you have any questions?
Not really. It's a question about, I don't know, can we see the zone as an execution context?
Yes, that's a good way to look at it.
So, okay, because it seems to me it's easier for me to understand if I see it as an execution context, and why is it important to be restored at the end?
Right.
Okay.
So the other thing that we do here is, I'm not sure if you're familiar with WTF. WTF is a web tracing framework, and it allows you to run. So let's actually run this. So if I do this plunker, can I get a pop-up here? If you run this plunker, which we showed earlier, what we can do is we can run it with WTF enabled recording. And when we do ABC, we can click and we can actually see what's happening in here. So we can see that the Angular zone executed here. We can also see that it executed here. And then it calls some updates to happen. And finally, the change detection happens over here. So all of the operations get nicely kind of painted for us. And so, for example, I think this was a key that got, this is a mouse, there is a mouse over. Somewhere there should be us typing, which then results in the individual operation. So the other advantage of Zone is that the zones can paint these beautiful pictures for you as to what's happening in a system. And so a lot of times it's kind of a head scratcher as to what's happening, why does change detection run or not, what zone I happen to be in. And so the Zone.js tries to help out with this particular problem by recording all of this information inside of WTF, inside of this nice charts that you see in here. And so that when you can go back, you can actually see, a particular zone is about to be executed. It finished executing over here. Or when the scheduling actually happens, we say, okay, we have scheduled a piece of work to be done later on. So that's what that piece of code is over there for.
Okay, so does this WTF has any performance impact on the actual zone execution?
That's a good question. So the function right here, the WTF set event function, when the whole thing is set up at the very beginning, there's a check to see if the WTF was injected in the page. So this plugin injects it. And If the WTF plugin has no injection, then as a result, all of these functions become just an empty no-op functions. The next step that happens is that the jitter notices that this particular function is called often, and so tries to inline it. And because the function is empty, jitter considers it a small function, and it says, that's as a candidate for inlining. It inlines it. The next step is that the optimizer runs across it, and it sees that there's actually no operations in there. And so as a result, it has no performance impact whatsoever if the thing is not enabled. Now, obviously, if it is enabled, if you do turn on WTF, there is a performance impact to your application. You are paying some time for recording all of this information. But I mean, it's not always, it's only when you turn it on.
Clear.
Yay for jitters and inliners, right?
Yeah. Okay.
So you can imagine how, we kind of talked about set timeout, but you can imagine the same exact strategy basically for all asynchronous APIs, right? For add event listeners, for XHRs, fetch promises, and so on and so forth.
Okay, I would have another question. So, how to manage zones? You were saying that WTF is used to see whatever zone was callback was triggered, and is there any possibility to manage? Do we have to take care of which zones are created and how to manage them, or do we have to know something that it's a key element in the application performance regarding the zones?
Right. So typically, the developer doesn't have to worry about zones. So in Angular, when you bootstrap the Angular application, internally, Angular gets a correct zone running and make sure that all of the kind of boot up process happens in the correct zone. And then going forward, the zone is just propagated automatically as you set timeouts and do promises and resolutions and observers and so on. So that kind of happens automagically after the fact. So for the most part, the developers don't have to worry about it. But there are times when you do, and mainly those are the cases where you are, for example, inside an Angular zone and you want to do something like an animation. And you say like, well, I really don't want to pay the cost of doing change detection on every single animation. And so you want to jump out of the Angular zone. So then there is mechanisms by which you can say like, please execute the next set of operations, but restore the zone to some other value so that all the subsequent asynchronous operations, happen with different rules. As I said, typically this is used for animation, but like you can imagine other situations as well. The other place you could do this with is, for example, if you're trying to debug an application and you're trying to understand what's going on, you might want to enter a special zone which kind of does extra logging for you so you can see what's happening. The other place where this is actually interesting, that's actually used at Google, is that we are often interested in measuring the perceived latency for the user. And that's a very hard problem because we can easily measure any one operation we do, but we're not interested in that. We're really interested in this long-term thing, like user clicked on something, and now some XHR went to the server, something came back, maybe multiple XHRs came back to the server. They came in in some order. Eventually, we have sufficient amount of data to transition the page from view A to view B, render the page, and only then can we actually consider the operation to be finished. And so what zones allows you to do is to say, ooh, I'm about to perform some user operation, enter a special user latency zone. And this user latency zone can then go ahead and can observe all of the XHRs that go out and wait until the number of XHRs is 0. And then when the number of XHRs is 0, it knows that all the work is done, right? And then it can report this information back to the server. And so you can imagine like this is an excellent way of collecting information about your application in production, because you can actually see the latency that's seen from the user. You don't just have this whole bunch of things where the user complains that the application is slow, and then the backend people say, well, our XHRs are fast, and the front end people say, well, our rendering is fast, so it must be the backend, right? And there's this kind of a nobody kind of knows what's happening. By tying it together in a zone, you can actually paint a nice graph, and you can see like, okay, so what happened is that the first XHR went out. When the XHR came back, yes, it's true that the number of outstanding XHRs have gone to 0, but as a result of that XHR, we then fired off 2 new XHRs. And the second XHR returned quickly. We could have rendered, but we didn't, because the third one, that one took a really long time. And when it finally returned, we were able to render. And now we can measure the whole time end to end and then report it back to the server so that something can happen in the back end. So these are the areas where knowing about Zone can help, and you can do some amazing things. But for the most part, the end-to-end, the day-to-day development process, you can kind of ignore and pretend the zones are not there. But they do give you this kind of insights into what's going on.
Excellent. Another question: can we use zones with web workers?
You can. So zones are not only can you, but like we actually do. So Angular does run in web workers. So a little side note. So Angular is written in a way where we are rendering rendering agnostic, and so you can run the whole Angular framework in the web worker, and obviously Angular requires zones to run, and so that works just fine. And then Angular will take the information about what to render and then serialize it across the message bus, and then sends it across to the UI thread, which then can render it on its behalf. But obviously, those are two separate instances, right? The instance inside a web worker and the instance you have inside of the UI thread, those are two separate instances of zones, and they're kind of independent.
Okay, so how does the rendering happen? Does it render the whole context starting from the root, or is it rendering only a smaller context, a smaller area of the page?
So now we're talking about Angular. We're not talking about Zone. So all the Zone really tells Angular is like, you said you were interested in asynchronous operations. I have noticed that if this particular asynchronous operation that you have said you were interested in has just happened, it looks like all of the microtasks have executed and the VM is about to exit. So if you want to do some painting, now is a good time, right? So that's basically where the Zone, what Zone tells Angular. So Angular takes over, and it says, well, I need to figure out what has changed. And so in Angular 1, there was basically just one strategy, which was change detection. In Angular 2, we actually have kind of a multiple strategies that we have. We have everything from obviously the change detection, which is way faster, to push notifications, and more importantly, the way the data flows in Angular 2 is it goes from the root components to children components. So it's a unidirectional data flow. So as a result, the change detections are way faster. One of the tricks to make them faster is that we worked hard to make sure that all of the field checks for dirty checking are monomorphic. That's a fancy word, but basically means that when the jitter generates the code, every time it comes across that particular read of that field, the object that it's reading out of has the same exact shape. Okay, and by having the same exact shape, the jitter can do all kinds of magical tricks internally to make that read extremely efficient. What that means in practice is that we have to generate essentially what a human would write, a code that says, take the context, now check A, take the context, check B, check C, check D, and so on. But by generating that code, this is all done automatically, obviously, by the framework for you. The jitter can make all of the call sites monomorphic, and they're very fast. I think monomorphic call site is something like 10x faster than a polymorphic one, so it's a significant speed up. So you're asking. So you were asking, how do we know what changed, right? So at this point, we go and we detect the changes. If Angular detects a change, then only that particular change gets pushed to the DOM, right? And because the changes are monomorphic, you can do many tens of thousands of checks per millisecond in Angular 2. So it's a pretty high rate before it becomes a problem. But if for whatever reason, it does become a problem, you can go to other strategies. So for example, you can go to the push model, which essentially says that we have a dirty flag, and the component, instead of dirty checking the whole component, we only dirty check the component if you set a dirty flag on it. So then we have a lot less work to do, right? So if you go to the push model, then you can just simply say, oh, this hasn't changed, therefore don't do anything. And so typical thing for people to do is that all of their leaf components are in the push model. So if your leaf component is something like a calendar widget, right? Calendar widget is pretty certain that unless a user has interacted with the calendar widget or the current selected date has changed from the outside world, it's pretty safe to just ignore everything that's happening inside of calendar widget. And so that's an example where you go in the push model, and unless the component decides to set the dirty flag on itself, there's really a no op as far as we're concerned. So in terms of this question started with like whether Angular updates the world. Now, Angular is very specific. It only updates those properties that are absolutely necessary. Even if you take a property and let's say its value is A, and then you change it to B, and then go change it back to A, then Angular will realize like, oh, nothing has happened, and will not push anything to the DOMs at all.
Clear. So the zones are totally, the zone library, it's a totally different library.
It's a different library. It's an independent project. As you can see in the URL, it's part of Angular as in our repo, but it is a separate thing that we recommend for others to use. And it has many implications. As you know, we talked about unit testing, we talked about tracking the application along stack traces. You can integrate it with existing applications that you already have and that are completely unaware of zones, and you can get insight into what's going on. So there's a lot of benefits to be used out of zones, which are independent. You know, the benefit that we get out of it in Angular specifically is that we want to know when change detection has to happen.
Okay. So it seems pretty clear for me. Do you have something else to show us?
I think that is all. I mean, that this is pretty mind-bending stuff, if I may say so.
Yes.
But I'm super excited about how the zones turned out. It's a really nice piece of work. To give full credit, by the way, the idea of zones did come from the Dart project. So Dart has something similar in there. And then when we saw it, it was like, oh, we need to have something like this for JavaScript. And so we ported it.
It's a small piece of code that does a lot of things. It's really, really interesting. A lot of people will get into it, I think. So another question, and I think that this is going to be the last one. And do you have some examples where the zones are used in a production application or?
So we have some internally at Google that we use. I don't think that they're public, but really any Angular 2 application has zones being used, right? Again, in that particular case, it's for the change detection. In the repo here, there are some examples that you can check out that do different things. So there's an example of doing profiling, WebSockets, etc., including the long stack traces. So this is worth checking out to kind of get a better idea of what one can do with zones.
Okay. Thank you very much, Miško. This was mind-blowing. And yeah, it was really nice to have you here. Thank you for taking your time. Probably we'll meet in the future with more interesting presentations.
Thank you for having me, and looking forward to it.
You can stop sharing the screen now so everybody can see you.
Oh, I didn't realize that you cannot do that at the same time. You can see me, and I'm pretty sure that the code is a lot more interesting than my face, but thank you.
Thank you very much. I'm going to stop the broadcast right now. Thank you very much for all the viewers. We had a total of 10 viewers at one point. So looking forward for more views. Thank you.